Welcome to our last video of Section 4, Debugging Strategies. Debugging a TensorFlow model has some unique challenges, particularly related to the fact that computations are done in a static graph after we've defined the operations. This can make the debugging process feel quite strange at first. Luckily, TensorFlow has some great utilities for debugging that we'll go over today. We'll start with TensorFlow's main debugging utility, TF-DBG or TF-Debugger. The TF-Debugger utility has a huge amount of functionality, so we will only have time to scratch the surface and go over some basic use cases. Next, we'll introduce the usage of the tf.assert functions for checking conditions in your graph building code. And lastly, we'll go over tf.print, a handy function that allows you to print out tensors interactively as the session is running. First up is the TF-Debugger tool. Here we see the most basic syntax for using this with a custom estimator. Through a training hook. TensorFlow has a nice built-in hook for us to invoke the TensorFlow debugger. If we now pass this debug hook in our list of training hooks, the debugger will be invoked at runtime. Let's look at this in more detail in our editor. So I'm now just in our model function, just under if mode is train. And here we see the creation of the debug hook exactly as we saw on the slide. In addition, I've made a function called over50 here. I'll expand that. And I've passed this function over50 to the add tensor filter of our debug hook. So what's that all about? Well, one useful way of interacting with the debugger is by defining a custom tensor filter function just like this. They're expected to accept two arguments, datum and tensor. The first of which is a debug tensor datum object, which is essentially just a data structure containing useful properties of the tensor, such as its name. And the second is the value of the tensor itself in the form of a numpy array. TensorFlow's debugger will call this function itself for each tensor, checking whether or not the condition returns true. This function does return a boolean. My simple function, over50, will return true if and only if the input tensor is our output probs tensor, and if there is at least one entry in its output probs above 0.5 or 50%. To actually use this and see how it works, we pass it to our debug hooks add tensor filter function, and we give it a name in the actual function itself. As expected, the debug hook will be used right here in our training hooks array. So let's see what happens now if we try to run the code. Here I'm just going to run a simple script, main debug, which just runs our main.py file. I just like to wrap it so that you have access to this exact set of values I've used and you can run the same script yourself. When we run it, the program starts building the training graph as usual, but then something different happens as soon as it finishes the first training step. So we wait and we wait and we wait. But I've done a screencast so I can speed it up. Here, it presents us with the TF-Debugger command line interface. We are shown some of the allowed commands to run, but the main command is just run, which will execute one training step, and then return to the prompt, allowing us to inspect the results. Let's try entering run and see what happens. Bunch of TensorFlow printout happens, as TensorFlow often does. Okay, now we see a huge list of tensors given back to us. These give everything we could ever want to know about our tensors just after the previous session run call. For example, I can inspect the output probs tensor by entering the lt or list tensor command along with -n to print all the tensors matching the regex I entered. It shows me 3 tensors whose name include output probs, and I can click on any one of those names to see more. I'll click on the tensor corresponding to the softmax output probs tensor, and bam, I can see all of its values. Pretty cool, huh? I can also click on any one of those names of the columns here before to see more. Various kinds of information. So what about that filter function I made? Well, we can use that by calling run like before, but also we now add the -f flag, F for filter, and the name of our filter over50. Now it goes back and runs and waits until it finds that condition to be true, and this time when it returns, it automatically goes to the output probs tensor, allowing me to click and inspect its contents. And there it is. So this is just a sneak peek at the TF-Debugger, and I provided a handful of links in the additional resources slide so you can see all this tool has to offer. Let's now move on to the tf.assert functions. On this slide, I've shown the general usage pattern that you'll see when using the tf.assert functions. You use it to check some condition is true, which is what myCheck represents. Assert thing is not a real function, if you were wondering. Then you'll typically enter a with the tf.controlDependencies block, where myCheck is the dependency, and this means that the code will not execute any further during runtime if the assert is violated, and an exception will be raised. Let's see a specific example with the code we've been using so far. So here we are back in our model function just at the beginning after we've gotten our embedded features from the glove embed function. And I have a simple working example where I want to make sure that our embedded feature tensor always has rank 3, representing batch by sequence length by embedding size. When I write that as a control dependencies on a tf.assert rank as shown here, assert rank embedded features is 3. I'm guaranteed that this will always be true, otherwise my program will crash. This is of course a rather trivial example, but it shows the basic pattern that you'll almost always use when working with tf.assert. Next, I want to scroll down to show the basic usage of tf.print, a handy function for printing out custom messages and tensor values during the runtime of our graph. In this example, I'll be printing out the value of our preds tensor. Now, fair warning, the way you do this is very strange and it takes a while to get used to, but basically tf.print makes its own print operation in our computation graph, and we treat it like we treat any other operation. Specifically, the standard way I'd print preds, as shown here, is I actually reassign preds to tf.print as shown, and you can think of this almost like a control dependencies in that preds still evaluates to the same tensor as before, but anytime it's evaluated now, we're guaranteed that the print operation will run as well, almost as if preds is passing through the print function. Indeed, that is exactly why we pass preds as the first argument to print, because print will return the first argument after it's done printing out the statement. The reason we pass in preds again in an array for the second argument is because that is the list of tensors that tf.print will actually print. I know it's very weird syntax, but again, the first argument just defines the tensor that will be returned by tf.print, the tensors that's passing through, if you will, while the list of tensors in the second argument is what actually gets printed. In most cases, these will be the same as they are in this example. And finally, I've shown some additional arguments you can pass, first n and summarize. First n will restrict the print statement to only print the first n session run call results instead of doing it for the entire training period, while the value of summarize will give the number of entries we actually want printed out. Often our tensors will have way more entries than we could ever possibly want to make sense of in a print statement, so summarize says just show me the first 5 entries. So let's see how this looks when we run the code. We start the program as usual, and the only difference we're going to see is that a printout will show for the first 10 results for preds, along with our custom simple message. Here they are. Notice how each message contains the first 5 values, which we set by passing summarize equals 5. Pretty simple, huh? That's all there is to that. That marks the end of section 4. We've gone over a handful of TensorFlow related utilities that can be useful for nearly all TensorFlow programs. First we explored the usage of TensorBoard, then we dove a little deeper into working with estimators, followed by some miscellaneous training tips to keep in mind, and lastly, some of the great TensorFlow debugging utilities available. As always, make sure to read through the links here for an in-depth look at the topics covered today. Up next is section 5, TensorFlow in production. You'll often hear people saying TensorFlow is the go-to framework for your choice if you're going to serve your models in a production environment. In the next section, we'll see why that's the case.